Hi friends! Walking around the website of a local internet flea market, I came across a very curious lot of an old laboratory power source. It seemed to me an ideal option for my new retro laboratory, so I called the owner who lived in another city and agreed that I would send a courier to pick up the goods. By the way, it cost me $60. The seller said that he didn't know whether the source was working or not. He couldn't turn it on, but he didn't understand in electronics, so he couldn't check its operation. I was already burning with the desire to get the block as soon as possible, so I spat on everything in the hope that even if there were problems, I could fix it. The next day, the courier took it, and a day later, I already had the block. Imagine my surprise when I saw its size and felt the weight of this Bulgarian monster from the time of a more developed civilization on my own back. TEC1300K was produced in the late 80s. The range of these TEC laboratory sources is very extensive. This sample is quite unique because it is multi-channel, or rather 7-channel, and at that time very complicated. Now let's speak about the characteristics of the unit. It has 6 unregulated voltage stabilized channels that produce different voltages: bipolar 5, bipolar 12 and bipolar 15 volts. The currents on the channels are different, and this is enough for most tasks. I note that these channels have protection of current. If the limit is exceeded, the output will simply turn off and the alarm indicator will light up, which is separate for each channel. 7th channel is fully adjustable both in current and voltage. It provides current from 0 to 1 ampere, but really it can be up to 1.4 amps. Voltage is adjustable from 0 to 36 volts. This is pretty good. So this channel is fully stabilized both in current and voltage. All channels have reverse polarity protection. There is a simple diode protection because the currents are small. On the front panel, there is a power switch with indication. Next, there are outputs of unregulated channels. In the upper part, there are switches. These switches will allow you to connect in series a pointer ammeter, which is located on the left, to any selected unregulated channel. The ground of all channels is common. Next is the adjustable part. There is a separate voltmeter and ammeter, knobs for adjusting current and voltage, and another knob in the face of a tuning resistor for smooth and precise current adjustment. There are indicators of the source operation modes, current or voltage stabilization. On the right side are output terminals and ground terminal. Cooling is passive. The source is made entirely of aluminum. On the sides are powerful radiators of huge sizes. The total weight of the device is 12 kilograms. Device produced in 1988 in Bulgarian city Mikhailovgrad, now renamed to Montana Plant Analyst. The design. On the side radiators, 6 power transistors, 2 and 3055 are hidden, 3 pieces on each radiator. Each of these transistors is responsible for its unregulated channel. They are isolated from radiators. Given that both transistors and radiators are quite powerful, it is almost impossible to heat and overheat this source. It can work for days at maximum power. Another pair of radiators with the same transistors is hidden inside the source. They are responsible for the regulated channel. The design is modular. All boards with components can be easily removed and serviced because they are on connectors. There is a silk screen on the boards, although they are without a solder mask, but everything is beautifully tinted. Then it was in the order of things, not like now, when anyone can order beautiful factory boards for every taste and color for their homemade products, and GLC-PCB is your faithful assistant in this matter. In addition to high-quality printed circuit boards of almost any shape, size, and number of layers, the company is also engaged in industrial 3D printing, the creation of soldering stencils for soldering SMD components, as well as circuit assembly. In a word, any desire for your money, and you can be sure of the quality. You will find a link to the GLC website in the description. You can see several similar stabilizer boards of unregulated channels. Although they are identical in appearance, there is a difference in components. The boards that I later numbered as 1, 2, and 3 are responsible for channels 5, 12, and 15 volts. On each of these boards, two regulators for the positive and negative arms are assembled. There are no differences in two arms components, only the negative arm is, as it were, mirrored, and transistors of a different structure are used. Trimmer multi-turn resistors are responsible for the whole voltage and current limit for each channel. 3 other boards are for regulated channel. Alas, there is no circuit for this device, so I'm sorry that I can't tell you in detail. We see the use of operational amplifiers 741, that is, this isn't a simple unit based on transistors alone, but quite a serious one. The seriousness is also indicated by the use of precision resistors and selected components. There are many gold-plated components. There are Bulgarian capacitors with palladium content, tuning multi-turn single-watt resistors SP5, textilite boards are hand-soldered with tin tracks looking beautiful. A 210 volt amperes power transformer is quite serious and with a large margin. Nearby is a separate board with diode rectifiers. In the center of the source is a block with capacitors. There are 8 of them at 4700 microfarad each. The filtering is also quite good. Diagnostics and repair. At the first inspection, it turned out that one of the adjustment knob was missing, which I was warned about. This isn't essential. One leg is also missing, which I wasn't warned about, but this is also a trifle. When you turn it on for the first time, the voltmeter needle immediately goes off scale and doesn't react to the adjustment knob in any way. This is already bad. The maximum output voltage is 60 volts instead of 36. This is clearly a problem in the stabilizer. At the same time, the current regulation is working properly. This gives hope that the power transistor of the regulator is working. Checking unregulated channels showed that except for bipolar 15 volts, all are in good order. In the 15 volt channel, the positive half gives out about 12 volts while the protection indicator always lights up and nothing at all on the negative arm. The ammeter is working properly, current protection on the other unregulated channels too. First of all, I took out and blew all the vertical boards, there are 6 of them. Then I carefully examined and noticed burned out resistors on one of the boards, as well as ring cracks in many places, so I transferred everything on my working table and carefully soldered everything. Then I checked everything I could. Low resistance resistors, diodes, Zener diodes, and some transistors. 5 boards out of 6 are fully functional. About the last board with burnt resistors, I will talk a little later. Even during this assembly, I noticed the remnants of the internal content of the capacitor in some boards. And then I found the culprit, the electrolyte burst at the negative 15 volt output. I removed it and cleaned everything that was splashed with electrolyte. KEA electrolytic capacitors, which are used here, are very ambiguous. I met them in perfect condition, but they were complete rubbish, so they are always worth checking. I randomly unsoldered several capacitors from different boards. In terms of internal resistance, capacitance and leakage, everything is fine, even the smallest ones, so I decided not to change anything. Then I switched to a thorough diagnosis of the board on which there are burnt resistors. I think this board is responsible for the 15 volt channel problems. The body of one of the small transistors was melted, but strangely enough, it is alive. I will say more. There are 6 transistors on this board, of which only that one remained alive. As a result, several resistors and the indicated transistors turned out to be faulty. I will change all. Small transistors marked 31 have a PNP structure, those marked 12 NPN. Without hesitation, I replaced them with a complementary pair 2N5551 and 2N5401, only the input is different. The specified pair is quite high voltage, has a decent collector current and gate, so I use it as a universal option for almost any cases. Larger gold-plated transistors are 2T6551 and 2T6821, NPN and PNP respectively. I decided to replace them with BD139 and BD140, another universal complementary pair that I always have in my arsenal. But the bullshit is that I apparently had fake ones and they didn't last long. I had to change them to Russian transistors. We can use here KT817 and 816 with the index V and G. There were misunderstandings with only one resistor which was break and burned out so that the marking on it is not visible except for the number 6. Fortunately, the other part of the board is exactly the same and the components are the same. The burnt resistor should have a resistance of 619 ohms. I didn't find such one, so there will be this solution. Resistors with power from half a watt to 1 watt are suitable here. After the repair work, the boards were cleaned with acetone and put aside for a while. Now we have to deal with the regulated channel. Why did it become unregulated and produce increased voltage? Because I didn't find any problems on the adjustment boards and the power transistors are intact, I thought about a variable resistor responsible for voltage regulation. And then I noticed a broken wire, and judging by the fact that one of the outputs of the variable resistor wasn't connected anywhere, this wire just came off from here. As expected, the unit worked. This is the case when the wire really came off. I set the output voltage with the trimmer to 35 volts. It was originally 30. The voltage regulation functions properly. The current is also regulated. Further, all channels were recalibrated and they give out the declared voltage very accurately. All protections operate properly. Results. Someone will ask, why all this? You still won't use it exactly. Why did you buy it? Reanimate it. After all, most likely it will gather dust in the attic. In general, you are right. I thought that it would be smaller, could be placed on my working table, and I will use a nostalgic for the times that I hadn't seen. But this monster will stupidly disturb when it is on the table. Considering all these, most likely in the future a 4-channel amplifier in the AB class will be assembled in this case. There are more than enough radiators here, and the front panel is directly created for a low-frequency amplifier. You don't need to drill something, SAT terminals for acoustics, all this is already there. I just have lancers and amplifiers, only music lying ground idle, or maybe I will leave it like that, the device is still cool. This video comes to an end. Links to my other resources and other useful information as always in the description. Now I say bye, until we meet again. With you as always was Kasyan TV.